Hello everyone, welcome to this session. In our previous session, we have discussed integral transforms, Fourier integrals, Fourier cosine integrals and Fourier sine integrals. In this session, let us solve some examples on Fourier integrals, Fourier cosine integrals and Fourier sine integrals. Now, working method to find these integrals is when fx function is provided in the question and if it is asked to find any one of these integrals, Fourier integral, Fourier cosine integral or Fourier sine integral, then we have to follow this working method. First read given question and write formula of the integral which is asked to find. Now identify given function f of x. After that write the formula of the integral which is asked to find. So here I have given the formula of Fourier integral, Fourier cosine integral and Fourier sine integral. So whichever is asked, you write that formula. Now if you observe in these formulae, a lambda and b lambda are there. So to evaluate any one of these integrals, first we should evaluate a lambda and b lambda. So to evaluate a lambda and b lambda, we have to follow these formulae. For Fourier integral, a lambda equal to 1 by pi, integral minus infinity to infinity, f of t cos lambda t dt, and b lambda equal to 1 by pi, integral minus infinity to infinity, f of t sin lambda t dt. For Fourier cosine integral, a lambda equal to 2 by pi, integral 0 to infinity, f of t cos lambda t dt. If Fourier sine integral is asked, then here find b lambda using 2 by pi integral 0 to infinity f of t sin lambda t dt. So after evaluating a lambda and b lambda, we have to replace these values in formula of integrals. Then we get required integral. But in some questions, they may ask to evaluate the integral directly. So question may be like this. Show that integral 0 to infinity cos omega x by 1 plus omega square d omega equal to pi by 2 e power minus x using Fourier integral. Here fx is not provided. Here they are asking to show value of this integral is pi by 2 e power minus x. To solve such problems, first we have to observe given limits and given integrand and RHS. So if given limits are 0 to infinity and this integrand contains cos terms, then use cos integral formula, and before that consider this RHS as function f of x. Consider RHS as f of x and consider cosine integral formula if integrand contains cos terms and limits are 0 to infinity. If limits are 0 to infinity and integrand contains sine terms, then use sine integral formula, and here also fx equal to given RHS. Then evaluate a lambda and b lambda which is required. Then use here relevant integral formula, sine or cosine or formula. After finding a lambda and b lambda, then replace those in Fourier cosine or sine integral formula which is taken. Then we get here this integral 0 to infinity cos omega x 1 plus omega square d omega. That means here we are going in reverse part. That means here we are considering RHS as f of x and we are using integral formulae which is relevant. Then we get LHS. Okay, here we are not evaluating integral directly. Here by taking RHS, we are proving this LHS. So here after taking RHS, then by observing these terms, we are taking integral formula. Then by using that integral formula, we get this LHS. Now, I have given 8 questions here. So let us solve one by one. Let us see first question. So here first question is express fx equal to 1 for mod x less than or equal to 1, 0 for mod x greater than 1 as a Fourier integral. So if you observe here in this solution, fx is, in this question, fx is already given. So if fx is given, first write that given function fx equal to 1 for, here 0 for. Here mod x is less than or equal to 1 means x is in between minus 1 and plus 1. If mod x is greater than 1 means x may be in the interval minus infinity less than or equal to x less than or equal to minus 1 and or here 1 less than or equal to x less than or equal to infinity. Okay, not or and. So here in both these intervals, this f of x is 0. That means if you draw a number line, here 0, 1, 2, 3, so on, up to infinity, and minus 1, minus 2, minus 3, minus 4, so on, up to minus infinity. Then here, in this interval, value of fx equal to 1. But in this interval and in this interval, fx is 0. Okay, so if mod x, here in general you can write if mod x is less than or equal to a, what does it mean? Minus a less than or equal to x less than or equal to plus a. And if mod x is greater than a means here minus infinity less than or equal to x less than or equal to minus a and a less than or equal to x less than or equal to infinity. Here mod x is nothing but plus x when x is greater than 0 and minus x when x is less than 0. So here by considering x is less than or equal to a and minus x is less than or equal to a, we get this. Here if x is less, here minus x is less than or equal to a means x is greater than or equal to minus a. What does it mean? Minus a less than or equal to x. So if you club these two, you get minus a less than or equal to x less than or equal to a. Okay, so here after rewriting these given limits, let us write integral formula which is asked here. It is asked to find Fourier integral. So Fourier integral formula is fx equal to integral fx equal to integral 0 to infinity a lambda cos lambda x plus b lambda sin lambda x d lambda. This is Fourier integral formula. So here we have to find a lambda and b lambda first. So here a lambda equal to 1 by pi integral minus infinity to infinity f of t cos lambda t dt and b lambda equal to 1 by pi integral minus infinity to infinity f of t sin lambda t dt. By using these two formulae, first we have to evaluate a lambda, b lambda, then we replace those values in this Fourier integral formula. So here first let us find a lambda equal to 1 by pi integral minus infinity to infinity f of t cos lambda t dt. Here this can be written as 1 by pi integral minus infinity to minus 1 f of t cos lambda t dt plus integral -1 to +1 f of t cos lambda t dt plus integral 1 to infinity f of t cos lambda t dt. So here the interval -infinity to infinity is divided into 3 intervals. First interval is -infinity to -1, then -1 to 1, then 1 to infinity. You know, in this interval f of t is 0, in this interval f of t is 1, in this interval again f of t is 0. Okay, by given function. Here you may think given function is f of x. Then what is about this f of t? No matter, here variable is changed, that's all. F of x equal to 1, 0. F of x equal to 1, 0. For mod x less than or equal to 1, this is for mod x greater than 1. This means f of t equal to here 1 for mod x less than or equal to mod t less than or equal to 1, and 0 for mod t greater than 1. So here for this f of t we can use value of this given function. That's why here in this interval -infinity to -1 f of t becomes 0, and in the interval -1 to 1 f of t becomes 1. So let us write this integral. So here a lambda equal to integral 1 by pi, integral 1 by pi is there. So 1 by pi integral -1 to 1. Here f of t is 1. You can write its value here. 1 into cos lambda t dt. That is equal to 1 by pi integral -1 to 1 cos lambda t dt. So here if you observe, cos lambda t is even function. Cos lambda t is even function. That's why cos lambda t is even function. Therefore, integral -1 to 1 cos lambda t dt can be written as 2 integral 0 to 1 cos lambda t dt. How? By using definite integration formula. Integral -a to a fx dx equal to 2 integral 0 to a fx dx. If fx is even, 0 if fx is odd. By using this definite integration formula, we can write this integral in this manner. So here this becomes 2 by pi integral 0 to 1 cos lambda t dt. That is equal to 2 by pi here integral cos x dx equal to sin x. So here we get sin lambda t upon lambda under the limit 0 to 1. Here you can write this as cos ax dx, cos ax dx, which is equal to sin ax upon a. So here we have used this integration formula. Now we have to apply limits. First put t equal to 1. So 2 by pi sin lambda upon lambda minus sin 0 upon lambda. And value of sin 0 is 0. So we get here sin 0 equal to 0. So minus 0 by lambda, which is equal to Here 2 by pi or 2 into sine lambda upon pi into lambda. This term vanishes because this is 0. So 0 by lambda is 0. So you get 2 sine lambda upon pi lambda. Okay, because this becomes 0. Now let us find b lambda. Here b lambda equal to 1 by pi integral minus 1 to 1 f of t sine lambda t dt. That is equal to again 1 by pi. If you divide this interval, integral minus infinity to minus 1 f of t sine lambda t dt plus integral minus 1 to 1 f of t sine lambda t dt plus integral 1 to infinity f of t sine lambda t dt. Again as usual, f of t equal to 0 in the interval minus infinity to minus 1. So here this becomes 0. Here f of t is 0. Here f of t is 1. Here again f of t is 0. If f of t is 0, then this whole integral becomes 0. So here we get 0 plus integral minus 1 to 1 into sine lambda t dt plus 0. That is 1 by pi integral minus 1 to 1. Okay, this is equal to 1 by pi. We have seen definite integration formula. Integral minus a to a fx dx equal to 0 if fx is odd function. So here sine lambda t is odd function. Therefore here this is 1 by pi into 0, which is equal to 0. Okay, so we got values of a lambda and b lambda. We have to replace those in f of x. So here f of x equal to integral 0 to infinity a lambda cos lambda x plus b lambda sin lambda x d lambda, which is equal to integral 0 to infinity. Here a lambda is 2 by pi or upon pi lambda cos lambda x plus 0 into sin lambda x d lambda, which is equal to 2 by pi integral 0 to infinity sin lambda upon lambda into cos lambda x d lambda. This is required Fourier integral. If they ask to obtain value of integral 0 to infinity sin lambda by lambda, here to obtain value of integral 0 to infinity sin lambda by lambda d lambda, put x equal to 0 on both sides of fx equal to 2 by pi integral 0 to infinity sin lambda by lambda cos lambda x d lambda. Okay, so here in this formula, in this integral, if you put x equal to 0, we get this required value. If you put x equal to 0, here you get f of 0 equal to 2 by pi integral 0 to infinity sin lambda upon lambda cos 0 d lambda. So here, so f of 0 equal to 2 by pi integral 0 to infinity sin lambda upon lambda d lambda, since cos 0 equal to 1. And here f of 0, what is value of f of 0? Here we know f of x equal to 1 for minus 1 less than or equal to x less than or equal to 1, and 0 for 1 is less than or equal to x less than or equal to infinity, or minus and minus infinity less than or equal to x less than or equal to minus 1. So in these intervals value of f of x is 0, and in this interval value of f of x is 1. If you see, we have drawn a number line here. Here on this number line, if you observe here 0 is existing between minus 1 and 1. So in this interval value of fx is 1. So f of 0, value of f of 0 is 1. Value of this function at x equal to 0 is 1. So here we can write f of 0 equal to 1. So here 1 equal to 2 by pi integral 0 to infinity sin lambda by lambda d lambda, implies here if you transpose 2 by pi to left hand side, you get pi by 2 into 1, pi by 2 into 1, or this comes in the denominator 1 by 2 by pi equal to integral 0 to infinity sin lambda by lambda d lambda. Therefore, integral 0 to infinity sin lambda by lambda d lambda equal to 1 by 2 by pi is nothing but pi by 2. So value of this integral is pi by 2. Now let us see next question. Next question is, find Fourier integral of the rectangular function fx equal to h into 1 minus mod x, where h is the Heaviside unit function. Here, by the definition, this u of t minus a equal to 0, 1 when t is less than a, when t is less than a, and 0 for t is less than a, and 1 for t is greater than or equal a. 0 for t is less than or equal to a, and 1 for t is greater than a. This is definition of Heaviside unit step function. So here interval is minus 1 to 1, and here this is f of x equal to this one. Here this is x. So here this one is 1 equal to f of x. So value of f of x is 1 by the definition of Heaviside unit step function. So here what is asked here? Function is given and it is asked to find Fourier integral. So first of all, let us write the given function and Fourier integral. So here fx equal to h into 1 minus mod x, which is equal to 1 by this definition, and Fourier integral formula is fx equal to integral 0 to infinity a lambda cos lambda x plus b lambda sin lambda x d lambda. Now we know a lambda equal to 1 by pi integral minus infinity to infinity f of t cos lambda t dt. So as usual here, if you split this integral, here minus infinity to minus 1, f of t cos lambda t dt plus integral minus 1 to 1 f of t cos lambda t dt plus integral 1 to infinity f of t cos lambda t dt. So if you split that integral, then in the interval minus 1 to 1, value of this Heaviside function is 1. In remaining integrals, it is 0. So here we get 1 by pi integral minus 1 to 1. Here this is 0, here 1, and here this is 0 according to definition. Okay, here fx is given. If you replace x by t, we get f of t. So here minus 1 to 1 cos lambda t dt. This is similar to integral of previous question. So here 1 by pi, again you can write this as 2 by pi integral 0 to 1 cos lambda t dt, since cos lambda t is even function. By definite integration formula, we can write like this. Now 2 by pi integration of cos lambda t is sin lambda t upon lambda under the limits 0 to 1, which is equal to 2 by pi sin lambda by lambda minus 0 by lambda, because sin 0 is 0, which is equal to 2 sin lambda upon pi lambda. This is a lambda. Now let us see b lambda. Even b lambda equal to 1 by pi integral minus infinity to infinity f of t sin lambda t dt. Here also we get the integral from minus 1 to 1 only, because in remaining intervals function is 0. So here value of f of t is 1. So we get 1 by pi integral minus 1 to 1 sin lambda t dt, which is equal to 1 by pi into 0, which is equal to 0. Since sin lambda t is odd, so integral minus 1 to 1 sin lambda t dt becomes 0 by formula of definite integration. That formula we have seen already in previous question. Integral minus a to a fx dx equal to 0 if fx is odd. By using this formula, this becomes 0. Now let us replace values of a lambda and b lambda in f of x. So fx equal to integral 0 to infinity a lambda cos lambda x plus b lambda sin lambda x d lambda, which is equal to integral 0 to infinity a lambda is 2 sin lambda upon pi lambda into cos lambda x plus b lambda is 0 plus 0 d lambda, which is equal to 2 by pi integral 0 to infinity sin lambda upon lambda into cos lambda x d lambda. This is required Fourier integral. Now let us move to example 3. Example 3 is find Fourier integral representation here. Show that integral 0 to infinity omega sin omega x upon 1 plus omega square d omega. 1 plus omega square d omega equal to pi by 2 e power minus x, x is greater than 0. If you observe here, it is not asked to find Fourier integral directly. By using Fourier integral representation, we have to show this integral equal to pi by 2 e power minus x. So here, if you see such questions, consider RHS as f of x. So here f of x equal to pi by 2 e power minus x. Let f of x equal to RHS pi by 2 e power minus x, x is greater than 0. Now observe the integrand. Here limits are 0 to infinity and here integrand contains sign terms. So here limits are 0 to infinity and integrand. The terms which are in the integral are omega sin omega x. So, and integrand contains sin omega x. Therefore, consider sine integral formula. Consider sine integral formula. So, if you consider sine integral formula, what is that? Fx equal to integral 0 to infinity b lambda sin lambda x dx. This is Fx sine integral formula. Now we have to find b lambda now. First find b lambda. So here b lambda equal to 2 by pi integral 0 to infinity f of t sin lambda t dt. So this is equal to 2 by pi integral 0 to infinity. Here f of t is pi by 2 e power minus t sin lambda t dt. Because if fx equal to pi by 2 e power minus x, then if you replace x by t, you get f of t equal to pi by 2 e power minus t. Okay, now let us evaluate this. Here 2 by pi and pi by 2 will get cancelled. You get integral 0 to infinity e power minus t sin lambda t dt. To evaluate this integral, we use this formula integral e power ax sin bx dx, which is equal to e power ax upon a square plus b square a sin bx minus b cos x. So here we use this formula to evaluate the integral. Now let us apply this formula here. So integral 0 to infinity e power minus t sin lambda t dt equal to, here a is minus 1 and b is lambda. So here you get e power minus t upon 1 plus 1 square minus 1 whole square, that is plus 1 plus lambda square into a sin bt minus 1 into sin bt, here minus 1 whole square, here minus 1, okay, into sin lambda t a sin bt minus b cos bt under the limits 0 to infinity. So here a equal to minus 1 and b equal to lambda. If you put these in this formula, put a equal to minus 1 and b equal to lambda, then we get this. Okay, that means here e power minus t upon 1 plus lambda square minus sin lambda t minus lambda cos lambda t under the limits 0 to infinity. So if you apply those limits, when you apply infinity, e power minus infinity upon 1 plus lambda square into this whole thing minus infinity, sin lambda t infinity. So here this is infinity form, minus infinity, minus e power 0 upon 1 plus lambda square into minus sin 0 minus lambda cos 0. When you apply upper limit, you have to put t equal to infinity, and when you put lower limit, you have to put t equal to 0. But here this becomes e power minus infinity is 0. This is 0 into infinity form, indeterminate form. So if you evaluate this, you get 0. Here this is 0. Okay, minus e power 0 is 1. 1 by 1 plus lambda square. Here e power 0 equal to 1. So here 1 by 1 plus lambda square into sin 0 is sin 0 equal to 0, cos 0 equal to 1. So you get 0 minus lambda, which is equal to lambda by 1 plus lambda square. So this is, what is this? B lambda. Now let us put this in f of x. Fx equal to integral 0 to infinity. What is that formula? B lambda sin lambda x d lambda, which is equal to integral 0 to infinity lambda by 1 plus lambda square sin lambda x d lambda. Okay, if you replace lambda equal to omega, if you put lambda equal to omega, this is integral 0 to infinity omega sin omega x upon 1 plus omega square d omega. Okay, so this is LHS. We have taken RHS and we have shown that pi by 2 e power minus x equal to integral 0 to infinity omega sin omega x upon 1 plus omega square d omega. Okay, understood or not? Here we have taken RHS. We have considered RHS as f of x, and at the end we got this LHS. Now let us see next one, fourth question. Fourth question is, using Fourier integral representation, show that integral 0 to infinity cos omega x by 1 plus omega square d omega equal to pi by 2 e power minus x when x is greater than 0. So here, even in this question, first observe the given integrand and RHS. Here also, using Fourier integral, we have to evaluate this integral. Using Fourier integral formula, we have to evaluate this integral. So here again, in this type of questions, first consider RHS as f of x. Let fx equal to pi by 2 e power minus x. Now here integrand limits are 0 to infinity, 0 to infinity, and integrand contains cos term or cos omega x. So consider cosine integral formula. Cosine integral formula. So cosine integral formula is fx equal to integral 0 to infinity a lambda cos lambda x d lambda. Now a lambda equal to 2 by pi integral 0 to infinity f of t cos lambda t dt. So here fx is pi by 2 e power minus x. So f of t is pi by 2 e power minus t cos lambda t dt. This is similar to previous question. Just in the place of a sine, here cos lambda t is there. That's all. Now here you have to use integral e power ax cos bx formula, cos bx dx equal to e power ax upon a square plus b square. Here a cos bx plus b sin bx. We have to apply this formula. Now here if you observe a equal to minus 1 and b equal to lambda, we get integral 0 to infinity e power minus t cos lambda t dt. Then use this formula, then you get integral 0 to infinity e power minus t cos lambda t dt equal to e power minus t by minus 1 whole square plus lambda square into minus 1 into cos lambda t plus lambda into sin lambda t under the limits 0 to infinity. We have applied e power ax by a square plus b square, a cos bx plus b sin bx formula. Now here when you apply these limits, here for this upper limit, when t tends to infinity, this whole term becomes 0. Then when t equal to 0, we get e power 0 by 1 plus lambda square into minus cos 0 plus lambda sin 0. Here value of e power 0 is 1. So you get minus 1 by 1 plus lambda square into, since cos 0 equal to 1, sin 0 is 0, you get minus 1 plus 0 in this bracket. Now this gives 1 by 1 plus lambda square. Now we have to evaluate the integral, right? So here, what is this? This is fx. Therefore fx equal to, what is this? Fx. Because here we got b lambda. So we have to find fx. Fx equal to integral 0 to infinity b lambda cos lambda x d lambda, which is equal to integral 0 to infinity 1 by 1 plus lambda square into cos lambda x d lambda. Here when you put lambda equal to omega, then what is fx? We have taken fx as pi by 2 e power minus x, that is fx, right? So pi by 2 e power minus x equal to integral 0 to infinity cos omega x upon 1 plus omega square d omega. This is required solution.